Alright, I'm going to give you 4 factoring examples so you can see different processes at work and see how I solve these problems. The first one here. First of all, I'm going to look for a GCF. I should always do that. This has no GCF among all the terms, no common factors, so I can't worry about that. I'm going to do the cross type of factoring that I've mentioned before, and I'm going to consider numbers that multiply to make 32. 32 times 1, 16 times 2, 8 times 4. Those are my choices for what I'm going to put on the left column over here. So let's try 16 and 2 and just guess that. We'll see how that works. Now over on the right here, I look at the number 3. That's either 1 times 3 or 3 times 1. Also notice the product is positive and the sum is negative. So the two numbers that I'm going to have to think about must both be negative in order to multiply to positive and yet give a negative sum when I check my work by foiling. So let's try negative 3 here, negative 1 here. So what we're getting out of this chart is the F, O, I, L of FOIL. We're reproducing that pattern. So having a look here, we can see we have negative 48, which is a very large number, much larger than this. And this diagonal gives me negative 2. There's no way I can combine those to get 20. So this is not the combination to use. Let's try putting the 3 here and the 1 here. Now I have negative 16 and negative 6. I combine those, it's close to 20, but it's not 20. What that's telling me, because I know I need 3, 1, my 16, 2 is wrong. A tip for you. I would suggest that you work with numbers that are near to each other. They just tend to happen more often than these extreme ones like 16, 2 and 32, 1. Alright, let's have a look again. So remember, 8 times 4 is 32. I got that covered, my F. Here's my O, negative 8. My I, negative 12. Negative 8 and negative 12 does make negative 20. My L, these two negatives makes a positive, so I've got my factoring successful. All I have to do is interpret the result. The 8 and the negative 3 combine this way, 8x minus 3. The 4 and the negative 1 combine this way, 4x minus 1. That's it, factored. We FOIL it to check our work, of course, but I know I'm right. Okay, let's move on. I'm going to show you another method for the second one. 4, 12, 18. No common factors. X squared here, but no x's over here. No common factors, no GCF. This one I'm going to use the method of saying sum negative 21 from the middle term and a product of negative 18. And I'm going to think about negative 18 times 4. So that's going to be negative 72. Now, I'd like you to think and push pause for a moment and think about different pairings of numbers that multiply to 72 but add to 21. And don't forget the product is negative, therefore one of them is negative, one of them is positive. So push pause, try that out, and then push play when you're ready to go. Alright, I assume you did that. The numbers are negative 24 and positive 3. Here's how I'm going to use these. I'm going to use them to rewrite this number. So negative 24 plus 3. Notice how the middle term of the trinomial has become these two new numbers. I'm going to keep the last term the same. I'm going to keep the first term the same. This is an equivalent expression. It's sure not factored though. Now what I'm going to do is I'm going to look at the first two terms as a group. Together they have 4x in common and they have a remainder of x minus 6y. Now let's look at the second group. They have 3y in common and they have a remainder of x minus 6y as long as I make that a positive that I withdrew. Now I'd like you to notice that this binomial and this binomial are the same and they're factors, so they are a GCF. So I'm going to divide them out and I'm going to write the remainder, and this came from here and from here. And what I've just written is the factored finished form of this. Factored finished form, alliteration at its best. Now, in this pattern, I call this sometimes the long cut. It always works, but it takes more effort to get there. Also notice that I had an x squared here and a y squared in the last term, and that all got taken care of by just recognizing that I need a y term in each of those second parts of the bracket. Okay, we're going to move on. third type. Okay, now this one does have a GCF. The GCF is 3. I'm always thinking about GCFs. I write the remainder. Great. Now I'm trying to factor that trinomial. I'm going to show you another different method for doing this one. For this one, now this is a bit of a strange method. I gotta say I don't particularly like it, but it works. I remove the A for a moment, and I multiply the C by the A. I think of two numbers with a sum of 5 and product of negative 36. Those numbers are 9 and negative 4. So what I'm going to do is I'm going to form two binomials. Put x in the first place. I put that 9 here. I put the minus 4 here. And now I reintroduce the 6 that I multiplied before by dividing by 6. I'm going to simplify these a little bit. 3 over 2 is the reduced form of that, and 2 over 3 is the reduced form of that fraction. Don't forget that 3 out in front. One more step to go. If the resulting numbers here are fractions, as these are, what you do is take the denominator and make it a coefficient on x, so that 2 goes there, the 3 stays behind, and that 3 goes up here beside the x, and the 2 stays behind, and a 3 out in front. And that's factored. And it is correct. You can check the work. Last one. This is also a trinomial, but this one, what's catching my attention here is that this term is something squared. It's 4x squared. This term here is also something squared. It's 3 squared. And this term is 2 times the first term of 4x times the second term of 3. Let's just check that. 2 times 4, 8, times 3, 24x. Yes, it is. This follows the pattern of a squared minus 2ab plus b squared, which leads to the factoring of a minus b all squared. So I'm going to write 4x minus 3 squared. And that's it. It's done. I hope those were helpful for you.